All right, today we have pre-calc lesson 11, not 10, 11, which is circles, properties of circles, and the quadratic formula. Some of this is review, some of this is not. Now, we have a lot of definitions with circles, okay? Now, we know that a circle itself, if we have a center, the circle is all points equidistant from the center, right? This is our circle. All of these points are equidistant array, meaning that our radii are always equal, okay? Now, let's talk about a radius. A radius connects from the center of the circle to any point on the outside of the circle. It's a segment that does that, okay? A chord is a segment that connects one point on the circle to another. Now, the diameter is a chord that passes through the center. That is our diameter. Okay? A secant line is any line that intersects at 2 points. Could be that. Okay, we'll see a lot of different versions of a secant. And tangent is a line that only intersects at 1 point. That's my point of contact. Just a small point of contact there. Okay, all of these we're going to have different formulas relating them and what we do with them. So you need to know what each of these are. A problem might say we have two secants intersecting, and you need to know what that is. Okay. We also know in a circle we have a circumference. The circumference of a circle is 2 pi r, and this is our perimeter. It's the perimeter of our circle. Okay. Now, we have arcs. So this is our circle. I have 2 points on the circle. The arc is everything that lies in between on the circle. Okay, it's not the segment here. It is everything that lies on this arc. Okay. A central angle is formed by 2 radii. And it could look like this. It's formed by 2 radii, which means it goes through the center. Okay. Now, we know that a central angle here, so if this angle was 60, then its arc angle is also 60. Okay. And we know in a circle is 360 degrees. Now, I know that's a little bit of a duh statement, but it's good that we remember that. We'll be using that in a lot of different facets. Okay, if we have 2 congruent circles, 2 congruent circles have the same radii. That's what makes them congruent. Okay, which means, obviously, in a circle we have the circle is all the points equidistant from the center, which are all of my radii. So if one circle has the same radii as another, then they would be equivalent. They would be congruent circles. Okay. More properties of circles. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. What does that mean? This is my circle. My inscribed angle means that it touches all the way to the other side of the circle. And if I said this measure was A and I said this arc was B, then the measure of angle A would be 1/2 the measure of B. Okay. Now, if I had an inscribed angle intercept the diameter, then that measures 90 degrees. That looks like, that's my diameter. If I have an inscribed angle that's touching my diameter, then the measure of that inscribed angle is 90 degrees. Okay, and one more, the sum of opposite angles in a quadrilateral inscribed in a circle, they equal 180. So, if I have a circle and I have a quadrilateral inscribed in my circle, a quadrilateral is something with 4 sides. If I said this was A, B, C, and D, then I know that angle A plus angle C adds up to be 180. Likewise, angle B plus angle D adds up to equal 180. Okay? So, let's jump into an example. Example 1. Okay, I have this circle here. And yes, you need to draw this, please. Okay, so this is 46, 30, x plus 10, and y plus 20. Okay, and I am going to grab another color. Okay, we need to find x and y. So if I look here, I have an inscribed angle A. Is it inscribed to this arc PR? Okay, and I have an inscribed angle here that is also inscribed to PR. They're both going to the same place, which tells me that y plus 20 must equal 30 because they are inscribed angles going to the same arc, which means that they are equal. Okay, and this tells me that y is 10. I apologize for the overhead speaker, but what can you do? Now, likewise, if I look here at this angle of 46 and here at this angle of x plus 10, they are both going to arc AB. So I can say x plus 10 equals 46, and x is 36. Okay, because they are going to the same arc, that means that they have the same length. Let's do another example. Example 2. Okay, this is 80, 75, z, x, y, 50. Okay, first I'm going to solve for x and y. I know that x plus 80 is 180 because opposite angles in an inscribed quadrilateral add up to equal 180. So x is 100. Likewise, y plus 75 equals 180. So y is 105. And if I look here at my inscribed angle there, 80 is an inscribed angle, which means it's 1/2 the measure of the arc, and the arc is this whole arc which is z plus 50. So to solve for 80, I'm going to multiply both sides by 2. So 160 is z plus 50. So z is 110. Okay.
Miss Smith, as in Miss Sarah Smith, can you please go to the front desk?
Example 3. We have this circle. We have z, x, y, 35, and 75. The first thing I want to do is find this little angle over here. I know that 35 plus 75 is 180 plus, I'm going to call that, let's call it w. Right? If I add up the three angles of my triangle, it equals 180. So that angle is 180 minus 75 minus 35, which gives me something. We have 180 minus 75 minus 35 gives me 70. Okay. Z is the inscribed angle to that. So 70 is 1/2 of z, right? Z is the arc. So z is 140. Y is the arc to this inscribed angle of 35. So 35 is 1/2 of y. So y is 70. And x is the arc to this inscribed angle. So 75 is 1/2 of x. So x is 150. Okay? All right, let's do some more properties of circles. So, properties of circles. The product of the lengths of chord segments equals the product of the lengths of the intersecting chord segment. So, if I said this was A, B, C, D, I can say that one chord is A times B, and it equals C times D. So let's do an example with that. We have this circle. Okay, so my one chord length I have here. I can do the product, 15 times x plus 10, and it equals my other chord length here, which is 20 times x plus 5. So 15x plus 150 equals 20x plus 100. I'm going to subtract 100, and I'm going to subtract 15x, leaving me with 50 equals 5x, so x equals 10. Okay, another property of circles that we have is two tangent segments from a point outside the circle have equal length. Okay? So, that's a tangent segment. That's a tangent segment. They have the same length, A and A. So let's do an example with that. Example 5. if I have this circle, and I have a tangent line, tangent line, tangent line, tangent line. Okay, this is x plus 4, 6, x, 10, x plus y. I know that these are equal. Obviously, x equals x. I can look here, though. I can also say that x plus 4 equals 6 because they are two tangents from outside a point touching a circle. They have equal length, so x is 2. Now over here, again, I have two tangents. They have equal length, so I can say x plus y is 10. I know that x is 2, so 2 plus y is 10, so y is 8. Okay? All right, let's talk about the quadratic formula. We are going to derive the quadratic formula. Ax squared ax squared plus bx plus c equals 0. I'm going to do this by completing the square. You do need to know how to do this proof. I will ask you how to do this. Fair warning. So divide everything by a. So x squared plus b over ax equals, I'm going to bring that over, minus c over a. Now I have my boxes. b over 2, b over 2 squared, parentheses, plus. My b term is b over a. If I divide that by 2, I have b over 2a. And if I squared that, I have b squared over 4a squared. I'm going to add b squared over 4a squared to both sides. Okay. Now on the left here, I have a factorable expression, and I factor it just like we normally do into x minus b over 2a squared equals, now I have minus c over a plus b squared over 4a squared. I want to combine these two into one fraction. So this term I have to multiply by 4a over 4a. So I'll have x minus b over 2a squared equals minus 4ac plus b squared all over 4a squared. You can see where we're headed. Now I take the square root of both sides. This side becomes x minus b over 2a. This side becomes plus or minus the square root of b squared minus 4ac all over the square root of 4a squared gives me 2a. I'm going to add this term over and I get x is b plus or minus the square root of b squared minus 4ac all over 2a. Notice I made a change. I accidentally put minus b over 2a. It should be plus. Made that a little anticlimactic, but nonetheless, if I subtract b over 2a over, now I have that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome for singing that. So let's do an example now that we know where the quadratic formula comes from. This is our formula. You do need to have it memorized. You should love it. Tattoo it on your body. It's fantastic. Okay, I will ask you to show this proof at some point. Use the quadratic formula to solve this equation. If it says use the quadratic formula, then you have to use the quadratic formula to solve. So we have x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is 2 over 6 plus or minus. We will have 4 times 3 times 5, the square root of 4 minus 60 all over 6, which Then I will have x equals 1/3 plus or minus 4 minus 60 gives me the square root of negative 56 over 6. Now I know that I can simplify 56 divided by 4. So I'll have x is 1/3 plus or minus the square root of 14 over 3i. Okay? Yes? All right, now here's another example. I want you to do this example in your notes. I will be checking for it tomorrow. Okay. That's x plus y, 19, x plus 3, 7, x, and x. I want you to find x. Solve that in your notes, and we will go over it in class next time. Goodbye.